September 1976, more than 4.5 years after President Nixon signed off on its development, America's new spacecraft, Constitution, gets its first close-up before the cameras. The orbiter itself was well received by the public, but impassioned fans of a particular long-canceled television series called Star Trek wanted it called something else. They staged a successful write-in campaign, and the orbiter was renamed for the Starship featured on the show. Thus, NASA's new shuttle would be the Enterprise, boldly going as no spacecraft had ever gone before. Whatever its name, this bird still needed to prove it could fly. In an age before computer simulations, balsa wood models and wind tunnel testing was the only means to test the airliner-sized glider.
We put together a very aggressive flight test profile that consisted of data points continuously all the way down. There was not a matter of 10 seconds went by without another either pitch doublet or a rudder kick or an angle of attack sweep. The things that really turn on a test pilot to fly them as accurately as possible.
August 12, 1977. On a crystal clear California morning, high above the Mojave Desert, 2 NASA test pilots ready for Enterprise's first flight. The plan was for Fred Hayes, Jr. and Gordon Fullerton to lift the orbiter off a modified 747, then land on a dry lake bed 15,000 feet below.
The thing that we were most concerned about was if we were going to be able to get to a launch speed, if Fitz-Fulton was going to be able to put the 747 into a slight dive so that we would have enough lift on the Enterprise to, when we did push the separation button, blow the bolts, to lift away from the airplane without hitting Fitz's tail. And of course, both of us were interested in that happening.
The pilots on the 747, Fitz-Fulton and Tom McMurtry, sit and wait for the command to release and steer their massive aircraft out from under Enterprise.
There were still questions about was it going to actually happen as we expected from those simulations and the analysis and everything. There's a very loud thump when the shuttle separates. There was always a question, was the shuttle going to slide back and hit the tail of the 747? But we couldn't see that, but we could, after a few seconds, we could tell it didn't hit us. And so the chase called clear.
Once we reached the 240 knots and Fitz called on speed, I think he really pushed some of the sensors he was looking at in order to let us get to there, and we appreciated that. But once we heard Fitz say on speed, I pushed the separation button and we just broke free. We had about 1.5 Gs of lift.
Honestly, that was probably the most exciting moment in the approach and landing test, to feel and be there when the shuttle separated from the 747.
By all accounts, this first freefall test is a success. 5 weeks later, Enterprise is brought to 22,000 feet for her second freefall test. Pilots Joe Engel and Dick Truly have only 2 minutes to capture flight and maneuvering data before landing the aircraft again without any engines.
It was a real team effort, and the challenge was for Dick Truly and I to fly that profile and fly those data points, those maneuvers, as precisely as possible to give them the best data possible. It was a test pilot's dream.
A total of 16 taxi, captive, and drop tests confirmed the soundness of the craft's design and green-lighted production of the first space-worthy orbiter. Columbia, NASA's first orbiter, is fittingly named after the first American vessel to circumnavigate the globe. However, Columbia quickly becomes a daunting challenge for NASA. Its complex makeup had engineers struggling constantly to reduce Columbia's weight and simplify construction. Especially frustrating was keeping the orbiter's ceramic tiles attached to its fuselage. More than 25,000 of them fit together to protect Columbia from the searing 3,000-degree heat of re-entry.
We were having a lot of problems with the thermal protection system of the tiles. The way we were trying to glue them on, they wouldn't stay on. And we had to come up with a way of making sure that they'd stay on. And we had some really great people that worked that, and that's why it took such a long time. I had hoped it was not going to take that long, since John and I were named as a crew, so we had a lot more time to train than what we'd both initially planned.
The requirement was to be able to handle temperatures like 2,500 degrees F that occur on the surface of the TPS, and that's 5 times what your oven is at home that you bake cookies under at max. The other problem is weight, because after all, this is an airplane, so you can't have a metallic system on it that weighs tons. It has to be extremely lightweight. And in fact, the shuttle tiles are about 90% air, and that gives the combination of being able to be temperature resistant and yet at the same time light.
Each orbiter has a unique number of protective tiles. Challenger was built with the most, 31,088, while Atlantis has the fewest, a mere 24,177.
Over in Palmdale, they had put on their first effort of putting the tiles on to protect the aluminum from the heating they were going to get on re-entry. And some of those tiles, when they'd put them on in the daytime, next morning the tiles were on the hangar floor. And so that was real scary, that we could lose some tiles while they were on orbit and really have a problem with the heat coming back on re-entry.
Columbia had a lot of tiles missing yet, needed quite a bit of work before we could deliver it to the Cape, and we scrounged throughout the city of Lancaster for RTV, which was the material we used to glue the tiles on with.
More glue did keep the tiles in place. However, water was literally ripping them apart.
It turns out, in the instant we hit rain, the tiles almost exploded.
The tiles fabrication process was modified and the problem overcome. Other shuttle design features proved less problematic and more groundbreaking. A computerized digital flight control system, now common in commercial and military aircraft, was developed for the orbiter.
In flying the space shuttle, you were so aware that you weren't necessarily talking to the shuttle, you were talking to a computer who in turn was going to talk to the shuttle.
Barriers of race and gender were falling everywhere, and America's corps of shuttle astronauts would become more reflective of the nation it served.
There's been a lot that the shuttle era has done to bring space flight into the domain of the average person. We know it's not just crew-cut white test pilots anymore. It's essentially the United Nations that flies on the space shuttles. It's people of every description that look very much like the rest of us.
The astronaut selection process reflected a changing nation and a changing NASA.
At the time, all the astronauts were military test pilots and there were no females, so it was kind of like one of those dreams that you hope will happen someday, but you didn't really think would.
The NASA astronaut class of 1978, the largest in the agency's history, came from all walks of American life: physicists, meteorologists, fighter pilots, scientists, and for the first time, women and African Americans.
When I came into the astronaut program in '78, there were 3 African Americans that came in at the same time, and it was the first time that NASA had hired African Americans. We had Fred Gregory, who was a test pilot, and then Ron McNair, who was a mission specialist, and I came in as a mission specialist. So all 3 of us were excited about flying in space, and we all 3 of us recognized that we were really going to open up the envelope for other African Americans to fly in space.
While the new class of NASA astronauts trained for subsequent shuttle flights, Columbia was undergoing preparations for the program's maiden voyage, STS-1.